Hello everyone. Let us now look into the next subtopic of our module arrays, what is called as multidimensional arrays. That is, from flat abstract presentations to dimensional data presentation. C enables an array of two or more dimensions, and the maximum dimensions actually depend on the compiler that we are using. Arrays having more than two dimensions are actually called as multidimensional arrays. More the number of dimensions in an array, more actually will be the complexity involved in the development of the source code. So far, what we have seen is the arrays that we have discussed were known as single dimensional or one dimensional array, meaning they were represented by a single pair of square brackets. Now look at that particular example that is there in front of you. You have this declaration statement int a of 10. Now this 10 is actually called as dimension of an array, which you are all aware. This is enclosed in the pair of a single opening and closing square bracket, and hence this type of representation is actually called as single dimension. Then the question that comes in mind is, what exactly you mean by multi-dimensional arrays? It's very simple. A multi-dimensional array has more than one subscript. That's the beauty of this. Say for example, if two sets are present, then it is two-dimensional arrays. So multi-dimensional arrays can be two-dimensional arrays or more than two-dimensional arrays. It's a very simple way to differentiate. If there is a single pair of square bracket, we call it as a single dimensional array. On the other hand, if the two sets are present, that is two pairs of opening and closing square bracket is present, then it is called as two-dimensional arrays. Similarly, if I have three pairs of square brackets, then it is called as three-dimensional. So, in a nutshell, just have a look at it. The first statement is single dimension. The second statement is two dimension, where I have 5 and 5. 5 is the dimension for the first, and next 5 is the dimension for the second. So, one of the important application where we use two-dimensional arrays are actually in matrix problems, where the first dimension 5 actually represents the row and the second dimension 5 actually represents the column. And the third declaration statement, I have three pair of opening and closing square bracket, that is 2, 3 and 4, which is actually called as three-dimensional arrays. Most of the applications involving around computer graphics actually makes use of three-dimensional arrays, where 2 represents the x-axis, 3 represents the y-axis, and 4 represents the z-axis. So, what I can say so far is a multi-dimensional array has more than one subscript. And multi-dimensional arrays make it easier to represent multi-dimensional objects such as graphs with rows and columns, or also probably the screen of the monitor. Now with this background about multi-dimensional arrays, let us focus on how exactly two-dimensional arrays works in programming language like C. So I have a declaration of a two-dimensional array. The syntax is like this. You have data type followed by name of an array, and both the dimensions are enclosed in a pair of opening and closing square bracket. So I have int a of 2, 2, which says that I am making use of two-dimensional array where the first dimension is 2 and the second dimension is also 2, and the array belongs to integer data type. So I have int as the data type, a is the name of an array, this particular 2 is called as row dimension, and this particular 2 is called as column dimension. Now, we have also seen in case of single dimensional array, C provides you to initialize the elements of an array. Similarly, C also allows the programmer to initialize the elements of a two-dimensional array. Something like this. You have int a of 2 is equal to, you have opening curly brace 10, 20, 30, 40, close the curly brace and terminate it by semicolon. So you know very well, whenever you want to initialize the elements of an array during its declaration, those elements are actually separated by comma and are enclosed in the pair of opening and closing curly braces. Now the question that comes is, what exactly, or rather, how exactly these two-dimensional elements will be stored in the memory? We have seen the total amount of memory capacity that is occupied in single dimensional array, and we also seen the memory map. So the way how we have drawn the memory map in single dimensional array, the memory map in case of two-dimensional array is also similar. But please try to understand that even though we make use of two-dimensional arrays, right, for theoretical concept or theoretical purpose, we discuss it as rows and columns. But as far as C is concerned, the elements of two-dimensional array also are stored in one continuous memory location. This is because C programming language follows columnar format of storing the elements as far as array is concerned. And hence, actually speaking, for C language, there is no concept of rows and columns. It is only for our convenience, we call it as rows and columns. And this you can very clearly see in the memory map that is given to you in front. So since array A is of having 2 rows and 2 columns, a total of 4 elements will be stored in this memory map, that is 10, 20, 30 and 40. Now assuming that this particular integer occupies 2 bytes and the base address is 101, so I have the address of other elements of an array, and hence the entire array starts from 101 and goes up to 108. Right? Now 101 up to 108 is totally 8 bytes. And hence the conclusion drawn is the amount of memory capacity that is taken by the two-dimensional array is nothing but row into column dimension into the size of the data type. Right? So 2 into 2 is 4. 4 into, assuming that integer takes 2 bytes here, so 4 into 2 is 8 bytes. And that is what you see in this memory map, 101 to 108. Now, we also have seen in single dimensional array that even though we declare the dimension, the array subscript in C starts from 0. And hence, the same holds good even in two-dimensional arrays. So, the first element of this initialization statement is actually called as A of 00. The second element is A of 01. The third one is A of 10 and the fourth one is A of 11. So A of 00 and A of 01, they are actually called as the elements of the first row. Similarly, A of 10 and A of 11, these two elements, that is 30 and 40, are called as elements of the second row. Now, apart from that type of initialization of two-dimensional arrays, C also provides you to initialize the elements in a slightly different fashion. So have a look at it. I have int A of 2 followed by opening curly braces, followed by another pair of curly braces where I have enclosed the first row elements. Then I have enclosed the second row elements, followed by curly brace and semicolon. Even this is absolutely valid in C programming language, but of course, the point to be noted is this will be with respect to corresponding loss in readability. And this is the prime reason in most of the cases we don't follow this way of initializing the elements of the two-dimensional array. Now, one of the important things you should note is in case of two-dimensional array, it is necessary to mention the second column, whereas first row is optional. Now, what exactly you mean by this? Just try to recollect when you initialize the elements of an array in case of single dimension. I had told you that whenever the programmer initializes the elements of an array during its declaration, C allows you to skip the dimension. And we have seen why it is necessary for us as a programmer to skip the dimension. And hence the question that comes in mind is, hey, if C allows me to skip the dimension in single dimensional array, can I skip in the two dimensional arrays? And the point that I want to tell is necessary to mention the second column, whereas first row is optional. Means like this. I have an array whose row dimension is 5 and column dimension is 2. So this is perfectly valid because I am giving both the dimensions. So I can go with this or I can go with this. If at all I am keen in skipping the dimension, I am allowed only to skip the first dimension. That is, I am allowed to skip only the row dimension. And hence, these two statements which are there in front of you on the screen are perfectly acceptable in any C compilers. On the other hand, if any one of you try to do this, what? You skip the column dimension, right? You give the row dimension, you skip the column dimension, or sometimes, lethargic attitude, we'll end up skipping both the dimensions. So, either skipping the second dimension, that is column, or skipping both the dimensions will never work. Your compiler will end up giving you syntax error, right? But my experience says two things. One, in case of single dimensional array, it is good you skip the dimension. But in case of two dimensional array, I always suggest and recommend you all to give both the dimensions. Otherwise, it's totally left up to you what type of methodology you want to follow when you are going to initialize the elements of an array in case of two-dimensional. Now, having known that, let us see how I/O operations are carried out in two-dimensional array. That means, how can I read the elements in two-dimensional array and how can I get the output, or how I can get the output on the screen in case of two-dimensional array. So I have two for loops, right? The outer for loop takes care of one dimension and the inner for loop takes care of two dimension. You will come across these type of statements in most of the matrix applications. So with the help of these two for loops, I am trying to input the value, the elements of two-dimensional array. So depending upon the value of m and n, the scanf statement will be executed, right? Now say for example, initially the value of I is 0 and let us say m is 5 and n is also 5. So I will be 0. So j will be 0, j less than 5, and hence what happens? The scanf, whatever the element you enter, will be stored in A of 0, 0. And then j++ gets incremented, it becomes 1. The next element will be stored in A of 0, 1. Similarly 0, 2, 0, 3, and so on. And once the control comes out of this inner for loop, the control goes to I++. The increment counter executes with respect to the outer for loop and the value of I will be incremented. But once the value of I is incremented, the value of j is reset to 0, and hence this scanf, whatever you enter the element, will be stored in A of 1, 0. The next will be A of 1, 1, A of 1, 2. Similarly, the operation takes place till the control comes out of both the for loops. Now this is how you will end up inputting the elements in case of two-dimensional array. And with a small change. And what is that change? Instead of scanf, I replace that statement with printf statement. And hence what happens? This particular for loop and the printf statement will print the value or the elements of the two-dimensional array what I have read at the top. Let us look at something called as parallel arrays. What do you mean by parallel arrays? The same subscripts can be used in two or more arrays at the same time. Such arrays are called as parallel arrays. The simplest example that comes in my mind as far as parallel arrays goes is copying n elements from one array to another. I'll just show you a simple example. I don't think I should give you explanation about this. I have a for loop which says for I is equal to 0, I less than n, I plus plus, and I just say b of I is equal to a of I. I assume all other syntax is taken care, even including the declaration statements. Now, when you look at this particular statement inside the for loop, that is b of I is equal to a of I am making use of two arrays. On the left hand side, I am making use of array B, and on the right hand side, I am making use of array A. But watch out carefully. In case of both the arrays, the subscript is same, that is variable I. Now that is what I mean. The same subscript can be used in two or more arrays. And in this case, both A and B are called as parallel arrays. Let us see advantages and disadvantages of arrays. The first advantage of array is it is used to represent multiple data items of same type by using only single name. We have seen this during the introduction of the topic itself. Second, it can be used to implement other data structures like linked lists, stacks, queues, trees, graphs. Actually, these linked list, stacks and all, they are data structures which you will be studying in the higher semesters. Third, as I've already told you in the introduction of two-dimensional arrays, they are used to represent the matrix. The fourth advantage is iterating the arrays using their index is faster as compared to any other methods like linked list, etc. Let us move to the disadvantages of arrays. The first disadvantage of arrays, we must know in advance that how many elements are to be stored in an array, right? And that is what you have seen in the declaration statement. In single dimensional, let us say you are given int a of 10. So you are knowing in advance how many elements you are going to store in an array. So in case of int a of 10, it is going to be 10. The second disadvantage is array is a static structure, means array is of fixed size. The memory which is allocated to array cannot be increased or reduced or decreased, right? Now in case of int a of 10, right, the array is of fixed size and that is 10. And suppose if we are using integer data type and integer occupies 2 bytes, then int a of 10 will occupy totally 20 bytes. Now this 20 bytes, neither it can be increased nor it can be reduced. And hence, this is the prime reason why array is called as static structure. Third disadvantage, since array is of fixed size, if we allocate more memory than requirement, then the memory space will be wasted. And if we allocate less memory than requirement, then it will create a problem, right? Now, what do you mean by this? If we allocate more memory than requirement, then the memory space will be wasted. Obviously, when I say int a of 10 and I do not make use of all the 10 elements, then the memory will be a wastage. Just imagine, right? If the dimension is 10, it is going to occupy 20 bytes. And in case of that array, if I store only 8 elements, that will occupy how many bytes? 8 into 2, that is 16. I have 20, but I am making use of 16 bytes, and hence what happens? I am landing up in wasting 4 bytes. And you know very well what happens if we allocate less memory than the requirement. You will land up in problem as a programmer. Let us look at the fourth disadvantage. The elements of an array are stored in consecutive memory locations. Absolutely no doubt about it. So at times, insertions and deletions are very difficult and time consuming. So keeping all these disadvantages of an array, right, what actually is available to programmer is to come out of this concept of static structure and move towards what is called as dynamic structure. Of course, we are not going to discuss about that here, but this is only for your information as of now, that you have something called as static memory allocation and dynamic memory allocation. Just to tell you at this point of time that dynamic memory allocation is basically a weapon to take care of all the disadvantages which otherwise as a programmer you will encounter in case of static arrays. Now, with all these things as a background, right, let us proceed with something that I love most, as all of you know, in C programming language. That is, find the validity of the following code. I request you to just spend some time in going through this and try to understand as to what I am trying to ask you in this particular piece of code. So I have an array which starts at 101 and assuming that integer occupies 2 bytes. So this is for your information. Declaration statement, I have a 2-dimensional array and I am initializing the elements of an array during declaration, and hence my array elements are 1 to 9. And then I am printing n, and I am printing n of 2, and I am printing n of 2. Now, at the first instance, when you look at this, majority of you land up telling the answer, within no time. And the answer would be, this will give you syntax error. Now, if I ask you why, you will end up telling that I am making use of 2-dimensional array in the declaration part, and somewhere in the printf, the second printf particularly, you are trying to print the single dimension. And hence, there's a dimension mismatch between the declaration statement and between the executable statement, and hence this will give you syntax error. But my dear friends, let me tell you, you are studying one of the most beautiful, popular programming language called as C. C allows you to have these type of things, and that's the beauty of C. Let me explain you, but before explaining, let me throw you the answer. The output of this code or the output of this program is 101, 113, and 9. Let us try to understand why as to how you land up getting this answer. First, let me draw the memory map for this declaration statement. I have n of 3, that means totally I have 9 elements, and my memory map is like this. I have given you a hint that, the information that you assume that your array starts at 101 and integer occupies 2 bytes. And hence, my first element is at address 101, and then I have 103, 105, and it goes up to 118. So 101 to 118, that is totally 18 bytes. The name of an array is n, so my first element will be 00, 01, and 02. So these 3 elements, 1, 2, 3, they are the part of my first row. Similarly, n of 10, n of 11, n of 12, that is elements 4, 5, 6 are part of the second row, and n of 20, n of 21, n of 22, that is elements 7, 8, 9 are part of third row. Now watch out carefully. Even though this is a single dimensional array, we have made an attempt to print the value of n. Now this particular n is not an ordinary variable in this program. It is an array, and hence it will print the base address. We have seen already in the previous video that whenever you refer an array, you always get the base address. And what is the definition of base address? It is the address where the starting element of an array is stored. And where it is stored? 101. And hence the first answer is 101. Let us come to the second printf, n of 2. Now, when you say n of 2, you're actually trying to print something related to single dimension. Hey, how is it possible? I have a two-dimensional declaration statement at the top, and then I'm trying to print a single dimension, right? Again, keep in mind, you are studying C language. Now, whenever you have a two-dimensional array, and as a programmer, you are trying to print it in the form of a single dimension, let me tell you, this dimension, what you have written in the square bracket, that is 2, this actually refers to the row. This actually refers to the row where exactly it is starting. But in that particular row, you have so many elements. And hence, the beauty of this is, whenever you say n of 2, you always get the base address where the second row is starting. Now look at this. You have n of 0, 0, 0, n of 1, 1, 1, and this is the place, n of 2, 0. This is the place where your second row is starting, and the address where second row is starting is 113. That is what I said. It will give you the base address. That is the address where your second row is starting. That is 113, and hence the output of the second printf is 113. And I don't need to tell you what will be the output of the third printf, n of 2, 2. Since you are giving both the dimension, it will go to the array and pick up the element which is present at the second row, second column. That is this one, right? N of 2, 2, and hence it will print 9. Now this is the explanation as to why you get the answer for this code as 101, 113, and 9. Let us have a look at matrix multiplication program. All of you are good at mathematics, and from years together we have seen programs, or we have seen problem statements related to matrix. One of the important program which is also there as a part of your lab is matrix multiplication program. So I'll just give you a brief about this particular program, and I request all the audience or the listeners to kindly understand this, code it in your respective compilers, compile it, and get the output and see how the program behaves. I have a couple of ordinary variables in the second line, or in the line immediately after main. I have 3 arrays whose dimensions I have kept as 10, 10. I can keep more also, that doesn't matter. And 3 arrays are A, B, and C, out of which I'm going to use the first 2 arrays for the matrix, and the resultant of that will be stored in another array called as C. With the help of printf and scanf, I'll enter the size of both the matrix. The first matrix row will be M, column will be N, and the second matrix row will be P and column will be Q. And the fundamental knowledge of mathematics says that if the column of the first matrix is not equal to the row of the second matrix, matrix multiplication is not possible. And that is what I am trying to do in the if statement, trying to say if n is not equal to p, matrix multiplication is not possible. And once I get this particular statement, with the help of this exit library function, I am going to come out of the program. So as of now, don't bother about this library function. We will be discussing it in the next module. So let us assume that the dimension or the order that I'm going to enter for the matrix is in such a way that the column of the first matrix is equal to the row of the second matrix. In which case, my if control structure becomes false and the control will come here. And then what I'm going to do is, with the help of this printf, for loop, and scanf, I'm going to enter the elements of matrix A. So whatever I enter will be stored in matrix A of 0, 0, A of 0, 1, A of 1, 0, 1, 1, like that. Similarly, I'll also enter the elements of matrix B with the help of for loop and another scanf statement. See the fundamental difference in the elements of matrix A. I have I is equal to 0 to m and j is equal to 0 to less than n. So here the test condition is involving variable m and n. On the other hand, in case of this for loop, that is the elements of second matrix, the test condition is actually being involved with variables P and Q. Now, once I land up entering the elements of the matrix, my next job is to do the matrix multiplication. Now, this is how my fragment or my code looks like for matrix multiplication. I'll have the test counter involved with the variable m for the outer for loop, and variable q will be for the inner for loop. And as I told you earlier, that the third matrix C I am going to use to store the product of both the matrix. So initially I will initialize the C matrix with 0, 0 for all the rows and the columns. And then I will use another for loop where K is the control variable, but P is playing a role with respect to the test counter. And this particular statement will actually do the multiplication for me, which is, I'm not telling new in this multiplication because it is coming directly from mathematics. C of ij is equal to C of ij plus A of ik into B of kj. And then I close the brace for the one for loop, and I close the brace for the second for loop, and I also have a brace for the third for loop. So once I do this matrix multiplication, I am going to now print the matrix, right? I'm going to use the for loop, and then I just print the product of both the matrix. Now this is self-explanatory, correct? The only thing is just have a look at the printf statement which comes immediately after the second or the inner for loop. The format specification I have given it as %3d. So what it does is it will just leave some space and then prints the value of the matrix or prints the elements of the matrix. Now that is given only from the readability point of view. Now that is how you land up developing the program of matrix multiplication. Let us also have a look at few other program statements which I have drafted for the listeners so that you can spend more time in programming, because the only way to master, to have a good grip on this particular programming language is to develop more and more programs that you come across. So I'll expose you to some of the programs. Already we have seen two programs related to single dimensional array, related to sorting and searching. So we have this bubble sort, selection sort, and linear search and binary search. Now apart from that, you can try writing programs for two-dimensional arrays. One is the matrix program for addition of the matrix. So I have the first matrix, this one, I have the second matrix, and the resultant matrix. I don't think I should explain you how matrix addition takes place. You can try the multiplication matrix, which we have already seen in the form of a program. So this multiplication is possible because the number of columns in the first matrix is equal to number of rows in the second matrix. And you know how the multiplication takes place. This 1 is multiplied by 5, and the result is added with the multiplication of this 2 and this 0. And that's what you have, 1 into 2 plus 2 into 0, that is 5. And similarly, all other elements of this matrix. Then you can also look at the transpose of the matrix where the row becomes column. So you have this row 1, 2, 3. It becomes as a column 1, 2, 3. You have this 4, 5, 6, the elements of second row. The same 4, 5, 6 becomes the elements of the second column in the resultant. Then you can try trace of the matrix, which is nothing but sum of the forward diagonal elements. Suppose if I have this as a matrix, the forward diagonal elements are 1, then I have 5, then I have 9. So 1 plus 5 plus 9 is equal to 15. And it is not necessary that you should do the sum of the forward diagonal elements. You can also do the backward diagonal elements, 3 plus 5 plus 7, right? Then let us look at something called as norm of a matrix. Now what is this norm of a matrix? The norm of a matrix is defined as square root of sum of squares of individual elements of the matrix. Suppose I have this matrix as 1, 2, 3, 4. you find the norm like this: square root of 1 square plus 2 square plus 3 square plus 4 square. So that is what you mean by square root of sum of squares of individual elements of the matrix. In this case, the norm of this matrix is 5.47. That is actually square root of 30. This is something beautiful. There is something called a sparse matrix, and a simple definition of sparse matrix is you have more number of elements in the original matrix as zeros, right? So that is called as sparse matrix. Logically speaking, if 50% or more than 50% of the elements of the original matrix is zero, we call it as a sparse matrix. So you can think of writing a program for that as well. The next one is row sum and column sum of the matrix. Very simple. You have this 3 cross 3 matrix, and then the addition of all the elements of the row, that is 1 plus 2 plus 3, which is 6. I write it on the right hand side of the row. Similarly, 4 plus 5 plus 6 is 15, so I write it here. This is called as row sum. And the column sum, so 1 plus 4 plus 7, which is 12, I'll write it exactly below that particular column. Similarly, 2 plus 5 plus 8, which is 15, I write it below that particular column. So this is called as row sum and column sum of the matrix. Then you can also think of writing a program to insert and delete an element in an array. Then another program, the statement goes like this: the first sequence D1 of a sequence A of n elements is obtained by subtracting each element except the last from the next element in an array. The second difference D2 is obtained as the first difference of D1, and so on. So you have this array 1, 4, 8, 7, 11, 14, 21. Now what is D1? D1 is obtained by subtracting each element. Now see here, you subtract 1 from 4. So I can just say subtract 1 from 4, that is 4 minus 1, that is 3. And then the next one is involving 4 and 8. So that is called as subtract 4 from 8. So that becomes 8 minus 4, that is this 4. And then you look at this, you involve 8 and 7. That means you actually subtract 8 from 7. So 7 minus 8 becomes minus 1. So like that you get D1. Then what is D2? D2 is 4 minus 3 is 1. Then minus 1 minus 4 is minus 5. So you get D2 like this. Then what is D3? Minus 5 minus 1 is minus 6. Right? Similarly, 4 minus of minus 1, that is 5. So this is D3. Similarly, you get D4, you get D5, and finally you get D6, which is nothing but 27 minus 0, that is 27. So that's what I meant, that the sequence A of n elements is obtained by subtracting each element except the last from the next element in the array. Just think of writing the program for this. This is another program that fills right to left diagonal of a square matrix with zeros, the lower triangle with minus 1 and upper triangle with plus 1. Just have a look at it. I don't think I need to explain you about this. It's as simple as. Now that's the beauty of this. This is my favorite program. Write a C code to develop magic square for odd dimension of a matrix. So the logic that I'm going to tell you works only for the matrix if the dimension is odd. So what we are going to do is, let us say we have a dimension as n equal to 3. So I'm going to develop a magic square for n is equal to 3. So what is the logic? The logic says you are going to place elements from 1. You are going to place elements from 1 to n square, right? Watch out carefully. You are going to place elements from 1 to n square. What is n here? 3, and hence you are going to place elements from 1 to 9. Okay, you are going to place elements from 1 to 9. So the logic goes like this. What you are going to do is you are going to place the first element in the middle of the top row. So I will place 1 here. Got it? I repeat, you are going to place 1 in the middle of the top row. Then you are going to place the next element 1 row up and 1 column right. Okay, watch out carefully. The next element that you are going to place 1 row up and 1 column right. So 1 row up is this. I don't have a row above 1, so I'll consider the bottommost row, this one. If I don't have a row above, I'll consider the bottom row, and 1 column right, I will place 2 here. Got it? Then again, I will repeat this line. I will say next element will be 1 row up. So this is 2. So 1 row is this one, right? And 1 column right is this one, right? And since I do not have a column on this, on the right side, I will consider the leftmost column, and hence I will place 3 here. So 2 things that you have to keep in mind here. If you do not encounter a row above, you have to consider the bottommost row of the same column, and if you do not encounter a column on the right side, you have to consider the leftmost column of the same row. Then I repeat, next element is 1 row up is this one, and 1 column right is this. So actually I have to place 4 here, but then this particular cell is already occupied, right? And hence, if the cell is occupied, what you have to do is you have to then place the next element exactly below previous element, right? That means what? You place the next element, that is 4, exactly below previous element. So that is 4 below 3. So I replace it 4. Then 1 row up, 1 column right, 5. 1 row up, 1 column right is 6. 1 row up, no row, come here. 1 column right, no column. So place 7 below 6. Then 1 row up is this. 1 column right, no column. So go to the leftmost column. So place 8 here. Then from 8, 1 row up, I don't have row. So I'll come to the bottommost row, and 1 column right, I'll place 9 here. Now watch out. This 3 cross 3 matrix is filled with all the elements from 1 to n square. That is 1 to 9. Now you add this matrix row wise, column wise, or diagonally, you will get the sum as 15. Watch out carefully. You will get the sum as 15. Now this is what you mean to say that write a program, you'll get sum as 15. So this is what it says. You write a program to develop magic square for odd dimension of matrix. And just for the homework, if you develop or if you take a piece of paper and solve this for 5 cross 5 matrix, the answer will be 65. Okay, so these are some of the programs I want you people to just try out, right? And ensure that you have a good programming experience. And let us come back where we have stopped. So that is what I have with you with respect to arrays. Now let me conclude what we have done so far. Arrays in C act to store related data under a single variable name with an index, which is also known as subscript. It is easiest to think of an array as simply a list or ordered grouping for variables of the same type. As such, arrays often help a programmer organize collections of data efficiently and intuitively. Even though arrays are supported in most of the programming languages in C, it is a little bit more special. Apart from being more convenient and more educative, it is also impressive in style and presentation. We have seen different types of arrays and their examples. And we also laid ourselves in the danger of exceeding the array limits. The computer won't give you an error. It won't stop you from crossing the borders. In fact, C acknowledges your acumen and assuming you are aware and ready to take the risks associated gives you that freedom. So you better know what you are getting into, because here you are on your own. Let's meet in the next topic called as strings.